Today, we are going to look at another topic, indices. What is indices? Indices is the area of mathematics that deals with numbers in index form. When we say numbers in index form, we are talking of numbers that are raised to a given power. A number in index form can be written in this form, as in a x raised to power n, a x raised to the power of n. This value can be said to be in index form, where our a can be a constant value, a constant, we call it a constant. Our x is said to be what? The base. Our x is said to be the base number, and while our n is what? An integer. An integer. And an integer, it can either be a negative value or a positive value. So example of a number that is in index form, e.g., we can have 5 raised to the power of 3. We can have 4 raised to the power of minus 2. We can have 2x raised to the power of 2, etc. All these values are said to be what? In index form. So when we carry out operations in mathematics with values that are in index form, we say that we are operating on what? Indices. That is the area of mathematics called indices. Now, today we are going to look at the basic laws of indices. The laws that guide indices. We are going to look at that. Laws of indices. Laws of indices. We are going to look at laws of indices. What are some of the basic laws of indices? We have 6 basic laws of indices, and they are: 1. Let's say a raised to power n times a raised to power n is equal to a raised to power n plus n. In the operation of indices with these various laws, we are saying that the base must be the same. Before these laws can be applicable, the base must always be the same. So a raised to power n times a raised to power n is equal to what? A raised to power m plus n. So we are adding. The second law is a raised to power n divided by a raised to power n. This is equal to a raised to power n minus n. Our third law, we have a raised to power 0. That a raised to power 0 is equal to 1. When any value is raised to the power of 0 is equal to 1. We have our fourth law here, a raised to power minus n. A raised to power minus n is equal to 1 all over a raised to power n. The fifth law we are going to take on indices, we have a raised to power n, open bracket, raised to power n. This is equal to a raised to power n times n. And the sixth one I'm going to take for the last now, we have a raised to power n over n. And this is the root of then raised to the power of what? N. We are going to look at all these laws. These are the basic laws of indices. We are going to look at them and prove them with simple values. We are going to prove the laws. Proving of the laws of indices. Let's see these various laws in basic application, how they correspond when we have them in our work. We are going to look at that. Number one. Now let's say we have 5 raised to power 3 times 5 raised to power 2. Now what's the meaning of 5 raised to power 3? 5 raised to power 3 simply means what? 5 times 5 times 5 into 3 places. Multiply 5 into 3 places. And 5 raised to power 2 gives us what? 5 times 5. So if we have 5 times 5 times 5 times 5 times 5, how many 5 do we have there? 1, 2, 3, 4, and 5. So our answer becomes what? 5 raised to power of what? 5. Which correspond to our what? 5 raised to power 3 plus 2. This is the same thing as 5 raised to power 3 plus 2, which gives us 5 raised to power 5, following the law of indices in our first law. Now let's look at number 2. Let's say we have 3 raised to power 5 divided by 3 raised to power 2. This can be written as what? 3 raised to power 5 all over 3 raised to power 2. This is what? 3 times 3 times 3 times 3 times 3 into what? 5 places. And we have what? 3 times 3. 3 raised to power 2 means 3 times 3. 3 cancel 3. 1 3 cancel 3. So how many 3 do we have left? We have 3 times 3 times 3. So it means 3 raised to power 3 times 3 times 3 will give us what? 3 raised to power what? 3. You can see that this corresponds with what we have said in the law of indices, where we say 3 raised to power 5 divided by 3 raised to power 2. This means what? 3 raised to power 5 minus what? 2. So 5 minus 2 will give us what? 3. So our answer, 3 raised to power what? 3. So we can see that these laws are correct. We can look at the third one. 1, 2, 3. Let's say 4 raised to power 3 divided by 4 raised to power 3. Now what is 4 raised to power 3? This means what? 4 times 4 times 4. All over what? 4 times 4 times 4. So we can see that 4 cancel, give us 1. 4 cancel, give us 1. 4 cancel, what do we have? 1. So it means that 4 raised to power 3 divided by 4 raised to power 3 is equal to 1. Is that not? And we said just now that 4, therefore, it means that 4 raised to power 3 divided by 4 raised to power 3. This is equal to what? 4 raised to power 3 minus 3. And that will give us what? 4 raised to power what? 0. Is that not? This is 4 raised to power 0. And we see that anything raised to power 0 is equal to 1. So you can see here now that 4 raised to the power 3 divided by 4 raised to the power 3. When we evaluate it, it's equal to 1. And when we subtract it here, it gives us 4 raised to the power 0. It therefore means that 4 raised to the power 0 is equal to 1. So we see that a raised to the power 0 gives you what? 1. Now let's look at another of the law that we are going to prove. Let's look at that. Let's say we have 4 raised to the power 2 divided by 4 raised to the power 6. 4 raised to the power 2 divided by 4 raised to the power 6. This will give us what? Following our law, we have 4 times 4 all over 4 times 4 into 6 places. 1, 2, 3, 4, 5, and what? 6. So 4 cancel here, 4 cancel here. So what do we have? This will now be equal to what? 1 all over 4. 1, 2, 3, 4 raised to the power of what? 4. So 4 raised to the power of 4, 1 all over 4 raised to the power of 4. We get that now. But we say that, look at that, 4 raised to the power 2 divided by 4 raised to the power 6 is equal to what? Is equal to 4 raised to the power 2 minus 6. And that will give us what? That will give us 4 raised to the power what? Minus 4. So what does that mean? It therefore means that 4 raised to the power 2 divided by 4 raised to the power 6 is equal to what? Equal to 4 raised to the power minus 4, which is equal to 1 all over 4 raised to the power 4. So we can see that the laws of indices, they are correct. Now let's look at one more. 3 raised to the power 2, open bracket, raised to the power 3. Is what? 3 raised to the power what? 2 times what? 3. And that is equal to what? 3 raised to the power what? 6. But if we want to evaluate this, what do we add? 3 raised to the power 2 bracket raised to the power 3 is the same thing as what? Open bracket 3 times what? 3 raised to the power what? 3. Is that not? So you can see that 3 raised to the power 2 means 3 times 3 raised to the power 2. That is what it means. Now, all this is also raised to the power of what? 3. So if all of them they are raised to the power of 3, this is now equal to what? Each of them raised to 3 gives you 3 times 3 times 3. This one again, 3 times 3 times 3. So how many do we have? 1, 2, 3, 4, 5, 6. So we now have 3 raised to the power of 6. So these are the laws of indices. In our next episode, we are going to use these laws of indices to solve basic problems.